Hello and welcome to another video. In today's video, we're going to be continuing to look at the area between two functions that do not intersect between 2 points. So let's get right to it with the first exercise. Let's write the formula first. Upper limit b, lower limit a, f of x minus g of x dx, where b is greater than a and where f of x is greater than g of x for all x's between a and b. Right? So let's write down our first function. F of x is going to be equal to x to the power 3 plus 3, and g of x is going to be equal to 2x plus 1. And we're going to be doing this from a equals to 0 to b equals to 2. Now, first we need to find which one is bigger in between these. So let's just apply 0, as it is very simple. Remember, we can apply 0, 2, we can apply 1, we can apply 0.3, we can apply 1.9, we can apply any value that is between 0 and 2, including 0 and 2. So let's apply 0, as it is very simple. 0 to the power of 3, 0 plus 3 is 3, and 2 times 0 is 0, plus 1 is 1. So f of x is clearly greater. So it's going to go first. Between 2 and 0, we have x to the power 3 plus 3 minus 2x plus 1 dx. This is going to be x to the power 3 minus 2x plus 3 minus 1 plus 2 dx. And this is going to be basically x to the power 4 over 4 minus x squared plus 2x applied to 2 and 0. So we see here that all of our values have x's. So if we apply 0 to them, it's just going to give us 0. So let's just apply 2 to the power of 4 over 4 minus 2 to the power of 2 plus 2 times 2. 2 to the power of 4 is 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. So we have 16 over 4, which is 4, minus 2 squared, which is 4 as well. So we cancel these two out, plus 2 times 2, which is 4. So we have 4 units squared, which is the area between x to the power 3 plus 3 and 2x plus 1 between the points 0 and 2. Let's solve another exercise. Our f of x is going to be x plus 2, and our g of x is going to be 6x minus x squared. And we're going to be solving it between a equals 1 and b equals 4. So first we have to make sure that f of x is greater than g of x. So let's apply it to 1. F of 1 is equal to 1 plus 2, which is equal to 3. And g of 1 is equal to 6 times 1 minus 1 squared, which is equal to 6 times 1, 6 minus 1 is 5. So no, our g is greater. And if we try it with any other value between a and b, we're going to get that our g is still greater. So in this case, following the formula, our g of x would actually be our f of x. So that is why you have to make sure and check really if your f of x is your f of x and if your g of x is your g of x. So we have to write this the other way around. 6x minus x squared, in brackets, minus x plus 2 dx, applied to 4 and 1. This is going to be basically minus x squared, 6x minus x minus 5x minus 2 dx. Therefore, we're going to have minus x to the power 3, 3, minus 5x to the power of 2, 2, minus 2x, 4, and 1. And now we just solve for these. It's going to be minus 4 to the power 3 over 3, minus 5 times 4 to the power 2 over 2, minus 2 times 4, and all this minus 1 to the power 3, minus 1 to the power 3 over 3, minus 5 times 1 squared over 2, minus 2 times 1. So now we're left with this. where we have that minus 4 to the power 3, 4 times 4, 16, 16 times 4, 64, 64 over 3, minus 5 times 16 is going to be 5 times 6 is 30, and then 5 times 1 is 5, plus 3, 8, so 80, 80 over 2, minus 2 times 4, which is 8, minus 1 to the power 3, minus 5 over 2, minus 2. This is going to be equal to minus 64 plus 40 is minus 64 thirds plus 40 minus 8 minus 1 third minus 1 third plus 5 halves, and let's say that this is minus 4 halves. This is going to be minus 64 over 3 plus 32 minus 1 third plus 1 half, which is going to be minus 64 thirds plus, and then 32 times 3 is 96 over 2 minus, and then this is going to become minus 2 sixths, and this is going to become plus 3 sixths, as we use minimum common factor. Minus 64 plus 96 is going to be 32 thirds minus 1 sixth. And so this is going to be just 64 sixths minus 1 sixth, which is 63 sixths, and this is pretty much 10.5, and that is in units squared, since it is the result for the area between 6x minus x squared and x plus 2 between the points 1 and 4. Thank you for watching. That will be all for today's video. Watch my next video, in which I will be explaining the final and third method of Barrow's theorem.